Sir, am I audible?
Yes, ma'am.
Okay. Good afternoon, sir. Good afternoon, all. It gives me pleasure to introduce a guest speaker of the afternoon session, Dr. J Vijay. Dr. J Vijay is currently serving as an associate professor in the Department of Biomedical Engineering, SSN College of Engineering, Chennai. He has done his research in medical image retrieval system for the PACS environment and obtained his PhD degree in medical informatics under the Faculty of Information and Communication Engineering from Anna University. He completed his master degree in medical electronics from College of Engineering, Guindy, and bachelor degree in electronics and communication engineering. His areas of interest include medical image and signal processing, machine learning, deep learning, medical system design, and antennas for biomedical implants. He has published research papers, books, and book chapters in reputed journals. With a small intro, I hand over this session to the guest speaker, Dr. J Vijay. Please, sir.
Yeah, thank you, ma'am. Thanks for your brief introduction, and it is great to meet you once again in this August program, and hope all the participants had your lunch. And it is very tough to handle any session, even it is online or offline. But hope I will make you more interesting. Whereas the particular topic which I will be handling is entirely different from other stuff like the image classification. And you want to see any video? So in order to refresh yourself, you can converse me through the chat window, and even if you have any questions, you can post your questions in the chat window. Okay, so whenever I start my presentation, this is my very favorite video. Just I will share. Hope you will enjoy. So, hope you would have enjoyed this video clip, which was running for about 5 minutes, right? So, with your permission, I switch off my camera, right? So, what are the aspects you observe from that particular environment, hospital environment? Could you say what are the technologies available in the automated hospital environment? Can you say? Can you type it in the chat window? You could see a lot of facilities, right? So many facilities you could see. So what kind of automation would be possible in future? Participants? Okay, so let us explain like the various like the image acquisition and even the image interpretation and even the tablets reminder. Everything is automated, and hopefully it would be possible maybe in near future, right? And so this is one thing like the automatic system what we can adapt it for the image retrieval system, and this image retrieval system is very essential in the case of the PACS environment. The PACS is picture archives communication system. And you could see a lot of literatures journals like which is stating about the image classification, and even whether it is benign or malignant, or whether what kind of disease is prevailing in a particular image. So that kind of interpretation is possible by any kind of CAD based system like a computer aided diagnosis system. But this retrieval is entirely different from the image classification system, and this is the very famous definition given by Edward Shortlife, whereas the medical informatics is the rapidly developing scientific field that deals with resources, devices, and formalized methods for optimizing the storage, retrieval, and management of biomedical information for problem solving and decision making. And here, just I am going to discuss only the retrieval part, right? The storage, even we have different storage mechanism. Um, we have cloud computing, edge computing, so many grid computing things are stuffs are available. But I am going to talk about only the retrieval, how the retrieval system would be possible in the case of medical decision making by the radiologist. And you are aware of the various modalities which are all available in any multi-specialty or super specialty hospitals, like even you can start from CT, MRI, PET, ultrasound, X-ray, and nowadays even the hybrid modalities are also possible if one particular modality is not functioning properly to observe the particular abnormality which is prevailing in the region, right? Anatomical region or any pathophysiological region. So for that, we can go with the hybrid kind of modalities, like we can take up the advantage of PET and CT, or PET MRI, SPECT CT, MRI SPECT, or MRI CT likewise. Right. So absolutely the final, the conclusion or the results would be like we need to provide the immediate solution for a particular case, right? So this is about the modalities, and um, but I am not going to talk about anything about the imaging modalities. I am going to talk only about the image retrieval system, right? So whenever you are approaching any scan center or the radiologist, immediately they will be asking you to stand in different positions, and based on the modalities it will be categorized as anterior posterior, posterior anterior, left lateral, and we have different directions. And if you go with the MRI kind of image acquisition, then you will be getting some sagittal and axial, or we have different directionalities, right? So once you go for any image acquisition, immediately the radiologist will be acquiring n number of images in different directionalities, and because each and every image will have some information, right? By consolidating all this information, then only the radiologist will be providing an adequate information, like what is the penetration of the particular tumor and all, right? So this is about the orientation what I told you earlier, right? So with these two images, right, I think you all know this is X-ray CT, sorry, chest X-ray. And but one thing you cannot observe unless otherwise we have some labels on the images, right? So whether it is anterior posterior or posterior anterior, that we cannot infer from this particular image, right? So can anyone guess what kind of orientation it is, whereas it is observed? Yes, this is posterior anterior and this is anterior posterior, right? So once even the information behind this particular image does not give you anything, right? Unless otherwise there is some annotation which is available over the image, right? So in the left part you have some, yeah. Uh, So you have left and right, some markings are available, unless otherwise you don't find anything, right? Whether it is observed in which orientation, right? And another thing is about, we have, again, we have two images, which is about the head anatomical information, whereas the image contains some brain information, right? Once again, you don't know what kind of modality it was captured, right? So it was involved, right? So this is another challenge which is available with the medical images, right? So this is MRI brain and this is CT brain, right? And another important thing is, like, still we have some unknown questions, right? But for this question, we are all aware of why the medical images are in grayscale model instead of any color model, right? So, so we all know that the color model, the color images containing three primary colors, right? RGB, and whenever you want to proceed with any kind of color images, we should have adequate computing power, and as well as the efficiency of the computing gadget must be high than any other gadget which is handling the grayscale model, right? So this is one particular example, right? Bowl which contains different kind of fruits, and I want to pick or retrieve, right? Here you need to retrieve an apple from this fruits, right, which is placed over the bowl. And so how do you pick a particular fruit from this bowl, right? So this is the question in front of you. This is the task given in front of you, right? So you have some computation tools and gadgets, but from this fruit, you need to retrieve or pick a particular object, an apple. How do you identify the particular object is apple? In what basis you will retrieve? Any idea? Right, absolutely, you will go with the feature, like the color, right? So if it is red color, then absolutely you will easily identify this is an apple, right? Okay. So even in few cases, the shades of the red is also prevailing in the neighboring object, and even if another task is given, like you want to categorize lemon and orange, right? Lemon and orange, but absolutely here the lemon is not available, right? So at that in that particular task, then you will be taking the texture as your primary feature, right? So here the feature is the prominent one, which is used to retrieve a particular object from a pool of objects, right? From a huge data set, right? So based on the features only, then we could go for any kind of classification or kind of a retrieval thing, right? Okay. Okay, but my image is like black and white, or it could be like grayscale, but here you cannot take the color as a primary feature, but still you can categorize the object apple and as well as banana or any other object like the grape, right? So that is also possible, right? So the traditional kind of feature selection or the feature based image classification or kind of retrieval is becoming outdated, right? So even that is not at all possible in the case of grayscale images, grayscale medical images, right? So the color is not taking place as a primary feature. So that's why we are not going to handle the color feature in the case of PAX environment, right? So apart from color, then we are going for different kind of features. Like we can majorly categorize as global feature or the local feature. Right. So apart from this, you can go with the energy, entropy, right? And even you can go for n number of feature extraction from your particular object. What I am saying here is, yeah, an image, right? So coming to this computer-aided diagnosis, and this computer diagnosis, which was evolved 20, 30 years back itself, and where they started programming and developing their own algorithm and applied on a particular modality for the purpose of observing an object in a particular image, right? So it acts as a secondary observer. So whereas it is used to investigate how useful the computer output would be for radiologists in their diagnosis, or how to quantify the benefits of the computer output, or how to maximize the effect of the computer output on their diagnosis. And for that, apart from that, we can go with different applications, like even you can quantitative the universal reference to your, for a specific medical image, and even you can apply this kind of CAD based system for the image retrieval in medical applications, and even you can go for the comparative study on images for better decision making and automatic recognition and post therapy healing process. So for all these purpose, where this computer aided diagnosis was developed, but whereas if you consider one particular algorithm or the methodology which you read from a particular literature, then it is not going to be a benchmark, or which is not going to be a kind of uh, yeah, universal reference, right? We cannot take it up like that. uh, so behind this computer aided diagnosis, we have different tools and algorithms. Even nowadays, we are talking about these bio-inspired algorithms, right? Which are all even the nature-inspired algorithms. All these algorithms, like neural networks, starting from neural networks, right? Starting from MP neuron, right? From 1960 onwards, right? Still, right? Lot and lots of algorithms are developed, but all these algorithms are applied on this computer aided diagnosis in order to go for the better diagnosis or better healthcare. But what is the limitation of this computer aided diagnosis is it is an application dependent, right? So once you develop a particular algorithm for a particular modality or a case or a abnormality, the same method would not be applicable, or it won't be that much efficient in the case of when you want to apply in different aspects. So the CAD implementation is an application dependent. What is the factor which is behind this application dependent is it's all about the features, what we consider the feature extraction method, the feature selection, or whatever the denoising methods, whatever the methods you adapt in your pre-processing, post-processing, or in your classification. It's all about based on the feature extraction and as well as the selection methods, right? So this is about the end, the conclusion or the outcome, right? Outcome of the CAD, so that you can improve the diagnostic accuracy of radiologists. You can lighten the burden of increasing workload. So whereas it acts as a secondary observer, and also reduce the error due to fatigue, overlooked, or data overloaded, and also it could improve inter and intra reader variability. All right. So nowadays we are talking a lot about the deep learning, right? Deep learning or deep convolutional neural network. But whereas the forefather of the machine learning and deep learning is the artificial intelligence, which was started in 1950 itself, right? And the ML and DL are the sub domains of artificial intelligence. So this artificial intelligence is important, or the going to be the required component in future healthcare. That is what I shown you in the movie, right? So if we are going for kind of automated system in the healthcare, then you can reduce the cost of the healthcare, right? And even you can improve the quality of the healthcare, and the burden of the physicians or the radiologist is going to be reduced, absolutely. Right. So once you go for any kind of the prediction, you need to categorize the data as into two or even more than two. Like you should have the trained data, training data, testing data, and as well as the validation data. And once you develop an algorithm like a machine learning algorithm or whatever the algorithms what we have seen earlier, then you have to train and you have to test the model, then finally the prediction would be possible. Right. So what is the difference between the machine learning and deep learning, right? So this is the object which I am giving to the system, right? Whereas the system which holds all these developed algorithms or the feature extraction or whatever the methods you proposed, right? So all these components, this is your CAD system, CAD based system. So once you provide test data and training data, right, you have to extract or you have to instruct the system to extract the features, right? Then you should go for the feature selection, right? And the feature selection is going to be the optimization technique. In the case of the feature extraction, then you can go for the classification, where you can start deploying any kind of classifiers in your classification stage. Then finally it would provide you the prediction as whether it is dog or not. But whereas in the case of deep learning, whatever the objects you provide, right, like the training data, testing data, right, so no need to instruct any kind of the number of features to be extracted from the object, right? So the system will take up uh, the the task like extraction and classification. So that is the advantage of deep learning. Why should I waste my time in instructing the features to be extracted from a particular object? That is not required, right? Even instructing about the classification, that is also not required. So my entire burden is taken by this system. So my thing is, I need to construct a particular model, like structured model, deep learning model, so that finally it would provide you whether it is dog or not dog, right? So the entire burden is reduced by this deep learning, right? Whereas in machine learning, you need to construct or you need to initiate each and every initiatives, right, stage by stage. So that is not required in the case of deep learning. Right. So this is about, once again, about the stages in extracting the features from a particular object. Like you need to go with image pre-processing, region of interest, feature extraction and selection, classification. So this is a step by process what we adapted for in the machine learning. And so once you finally get the predictions, then the predicted results will be given to the radiologist for the further diagnosis. Right. So if you take up the neural network, then you can go with initializing the number of layers, input layers, output layers, hidden layers, what is the weights, bias, and what kind of activation function I need to initiate between the input layer and output layer, or hidden layer. So everything needs to be done here. But here also we need to initiate the same thing, but mm, uh, uh, the number of parameters, it is going to be even you can go with some optimizer, right, so that it would reduce the efforts taken by the particular programmer, right? But what is the limitation of the deep learning neural network is what is actually happening within this input layer to output layer, so that is not known. So which acts like a black box. So whatever the inputs you give it to the input layer, then finally you will get it from the output layer. So when to use this machine learning and deep learning, you may get a doubt, right? So I have only 10 images, or I have only 100 images, right? So is it possible to apply the deep learning for these 100 images? That is not at all possible, right? So you should go with big or even more than or even terabytes of data when you want to deploy a deep learning model, right? So the data dependency e- uh, is excellent in the case of deep learning when you are going for the big data set. And absolutely we should go with some kind of workstation. You should in order to handle a terabytes of or even petabytes of data, right? But what is the advantage of using the feature engineering, right? So no need to give any kind of instruction to the deep learning, right? So what to be extracted, so that is not required. And execution time, absolutely it would take much time because your data is going to be bigger and bigger, more than that, right? And but interpretability is difficult, right? Already I told you this is like a black box, right? So this is the summarization of the utilization of the deep learning, use of deep learning, right? The training data set is small, large feature choosing features is possible in machine learning, but whereas in deep learning it is not possible. And number of algorithms, it's keep on growing, right? In the case of deep learning, and training time is longer. And in order to reduce this longer time duration, right, to perform training, absolutely we should have high power computing. So you can go with any workstations kind of stuff. Right. So coming to this task, we can have retrieval task and classification task. So with retrieval, which have no fixed classes, and classification, right? So you can go with the different kind of class specific training and all. So what is mean by retrieval task? So the simple example is like you just take up the Google search engine, right? So your internet is having a huge database, right? So whatever you want, right, you can search it from the Google search engine. So Google search engine, which acts like a platform, right, between the user and the database, right? So whatever you need, so you will immediately provide some text or keywords, right, as an input to the Google search engine. So based on your keyword, immediately it will retrieve. Right. So, so in that particular case, you could see, just stop it here for your understanding, right? I think you can able to see my screen, right? So here you can type like Vijay, right? So immediately you will get some actor or some other person, right? So still I want to get my image, right? My own image, right? Maybe I need to go with the second trial, right? So in order to get my own images, right, Vijay Jayakumar is the appropriate keyword, so that immediately you will be getting, right, my own images, right? So so this is a trial process, and which makes more discomfort to the particular person, right? So when you go for a particular objects to be retrieved, so here you can find out a particular camera kind of icon. So what is that icon, right? So this is actually whatever the process what I am giving here, like providing text as an input to the Google search engine, is a text-based image retrieval, right? So here there is one more option. So here you need to paste the image, or you need to upload the image, right? So you are giving image as a query and retrieving the image, right? So this is called as content-based image retrieval, right? So the content-based, so what is the difference between the text-based and content-based image retrieval? Yeah, just before that, just I will give you, this is the PAX environment, picture archives and communication system. So here you could find lot and lots of modalities, right? Imaging modalities are available. And if you take a particular example, like maybe this is very old data, right? In 2009, the Department of University Hospital of Geneva is generating like 114,000 images a day in 2009, but it's keep on growing. And per day, if you come across any kind of super specialty hospital, the number of images growing each and every day is in terms of terabyte or more than terabyte, right? So as per NABH, so last or past 10 years, data must be preserved and it must be stored in a particular repository, right? You just think about how much amount of data is generated for the past 10 years, right? It is very tough to store those images. And even in any cases, if you want to recover or if you want to retrieve a particular person image from a huge database, then you cannot go with any kind of text-based image retrieval because it takes much time, right? So for that purpose only, we can go with content-based image retrieval, right? So what is the advantage of PAC system? It's all listed here, right? So I don't want to read once again. So this is TBR and CBR, and whereas the text-based image retrieval, advantage of using text-based image retrieval is very easy to handle and simple algorithms are available, but the disadvantages are more like you should have time, you should have some time to retrieve a particular object, right? And most expensive, and subjectivity of human perception, right? So if I go with Vijay, then I could get some irrelevant data. So finding the appropriate keyword is very, very essential, right? So instead of that, you may ask like, why can't we go with patient identifier? But once again, the patient identifier, patient ID is not uniform across the globe, right? Each and every hospital is following their own patient ID, right? If you are going for the interconnection of the hospitals, right? If you want to connect all the hospitals in India, right? Then again, this is the problem, right? Right, but whereas in the case of content based image retrieval, you will be uploading only images, the features from the particular images, the images are extracted, and based on the feature similarity, the images which are all available in the database would be retrieved, right? So that is the advantage. So whereas it is going to be automated, but whereas the text based image retrieval is the manual one. Right. So this is the summary. Like we can go with text-based, content-based, or semantic-based image retrieval. But what I have done, right, it is going to be the composite one, right? Like I am just adding the advantage of the text-based and content-based image retrieval. This is the framework what I have created. So during my work, during my research work, and so what I told you earlier, so whatever the images are available, right? So which are all categorized into training images and user query images. And just based on the literature, I extracted all the features from both the images, training and testing images. And based on the feature similarity, right, the comparison will be taken and it will be displaying the images, right? So for that, I need to go with the different similarity measures, starting from Euclidean, Manhattan relative, Magalano-Bayes, cosine, Chebyshev, Spearman, and here PA stands for the feature of the input image, and QA is the feature value of the data which is available in the database. So I need to compare, I need to find out what is the difference between these two features, right? So each and every similarity measure, it does the same thing, right? So after retrieving the images, I need to evaluate my system, right? So for that, I could go with two similarity measures, right? Precision and recall. It is as similar like our confusion matrix, right? The confusion matrix is available in classification system. So there you will find out false positive rate or true positive, false positive, and so based on that we could find out what is sensitivity, specificity, and so many measures are available in the classification system as similar to classification system and confusion matrix. Here also we have two measure, one is precision and another one is recall. So what is that? The retrieved, it should be relevant. Okay, that is correct retrieved, which is termed as A, and retrieved but which is not relevant to my query. So it is incorrectly retrieved, and which is B, and this is not retrieved but the relevant items are retrieved. So this is missed one, and the last one is correctly rejected. So not retrieved and not relevant. So this is termed as D. So whereas precision is A divided by A plus B, recall is A divided by A plus C. It's very simple thing. This is what given here, and whereas F score is the product of precision and recall. This is the third measure, right? So these are the three performance measures which are all used in the retrieval system. And so for my work, I got the data from my university, Aachen University, and where I had only 12,000 images. Out of these 12,000 plus images, 10,000 images were categorized as test database, and remaining 2,000 plus, right, images are taken into account for the 2,000 for the testing, and 10,000 for the training images, right? And again, the entire database was split into homogeneous and heterogeneous, because in PAX environment you will get only heterogeneous images. It's all like a mixture of all kind of stuff, right? So what is my novelty? You may raise a question. These image retrieval systems are already available, so what you have done in your work? So whatever the articles you read in the literature, so which is giving the retrieval system for a particular anatomy or for the particular modality. But what I have done, I have taken a mixture of all the images, right? Proposed a method. So whatever the images I have given, so it should retrieve the similar kind of images from the heterogeneous database. So that is what I proved. So this is my sample of query images, and their description is given. All the images are only X-ray images. Still, I didn't go for any kind of diversified modality, only X-ray images, but different anatomy and directionality images were taken, right? So based on the comparison, what I told you, like the feature comparison between the training and testing images. So based on the simple distance measures, starting from Euclidean distance, Euclidean to Spearman, I tried with all comparisons between the training and testing. So if you could observe the first image, right? This is the heat X-ray image, but whatever the images retrieved, right? All like extremity and mammogram and skull. So some relevant images were also retrieved, right? It's all not related. But in the case of Corify, you could see the X-ray lung image, right? But almost all the images are considered. So you may ask, so what kind of features you have extracted? Almost I have extracted 199 features, right? So it's all based on the literature. 199 features were extracted, like entropy, correlation, energy, entropy, and Tamura features, right? Under Tamura, we have so many features, and even I applied DWT, DCT. So all these features, 199 features were extracted from each and every image, both from testing and as well as training images, and all these features were compared. And in this particular query image, my features, right, the training and testing image features are similar, but whereas in the case of the neck image, the feature vectors of the training images are not that much related to my query image. So this is the problem in my simple comparison, the simple image retrieval system, right? So here you could see the maximum precision is attained for this mammogram images, but very least value for the case of foot and kind of neck. So what I can do, I need to go for the optimization of the features, right? So whatever the features I consider 199 features, so all those features may work or may not work, right? As like our previous case, what we have seen, like the color and shape or texture, right? In the case of categorizing apple and lemon or lemon and orange, right? So in this case also, some features may be useful in the case of predicting the chest X-ray image, but it may not work for the neck X-ray image. So feature selection is required. So in order to go for the optimal, to get the optimal value. So for that, we go for different types of approach, like we can go with filter approach, wrapper, or embedder approach. But whereas this embedder approach is very much useful in my work, right? Whereas you can generate a subset, and the learning algorithms can also be initiated, and the performance can also be given as an input to the to generate a subset, right? So that's why I have taken the embedded approach. In order to perform this, Veka is one software. It's a data mining software. So you can take it up the advantage of the Veka, and whatever the features extracted, I just uh, 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 given to the Vecca software, and which extracted and given order of the subsets which are all useful for my work. Right. So based on the suggestion from the feature selection, right? So I could go with different types of the feature selection method, that is correlation feature selection, ranker approach, or genetic, or even more than the principal component analysis. So with this different approaches, right, feature selection approaches, then I could go with the maximum, or even if you take up this different similarity measures, if you take up the Mahalanobis, right, similarity measure, in the case of, if you take up all these 199 features, it gave me only 0.4 as a precision. But if you go with the ranker, or the in the case of applying genetic, we got 0.7, right, or else 70 percentage. But the same case of query 2, like a head image given, right, it again it has been reduced. When you consider the all features, it's only about 5%, and again it is the genetic, right, it's not giving it's not giving 70% or more than that, right? So what is the observation from this thing is, like, the again, even if you apply feature selection methods, right, using different algorithms, even there is some fluctuations in the precision value, right? It is not uniform, and there are still some ups and downs. All right. So for that, I just taken the ant colony optimization technique, right? So in the previous case, like genetic principal component analysis, I couldn't achieve that much efficiency. The efficiency here, it is a precision actually. So I just chosen ant colony optimization. I think you all know so how the ant behaves when they search for a food, right? So I think they are you all know the nature of ant. So whenever it goes to goes from one place to another place, it always deposits some kind of pheromone at the tail of the object, and the another ant will follow, right, accordingly, because the ants are not having eyes, right? So it's all based on the pheromone and the deposition of the pheromone. Each and every ant it follows, and so that it could find the shortest path, right, shortest path. So whereas this ant colony optimization is useful in the case of routing algorithm, and even for the feature selection also we can use this. So here the similar kind of stuff is taken here. So each and every feature is considered as an ant, and so whatever the features are related, then the subsequent features will be following, right? So this is what I have taken, and the pheromone and other kind of stuff, like the pheromone deposition and the number of iterations, all the parameters were initiated along with this ant colony optimization. And also I have given taken the advantage of relevance feedback mechanism. All right. So this is the entire algorithm. So I think it's all based on the behavior of the ants, right? So I don't want to go to anything. Here I have taken the advantage of the relevance feedback mechanism, and based on the inputs from the relevance feedback mechanism, the ant colony optimization and its pheromone would be updated. Right. So this is weighted relevance feedback mechanism, and even I should focus on the ordering of the objects sequentially in my screen. It should not happen like the relevant object should not placed in 1 and 10, right? All my relevant objects must be sequentially appeared. So for that case one, also I have taken the advantage of the ranking as well, right? So all those stuff are included within this algorithm. So here you can observe for the query 1 using the Euclidean distance, right? So I got the maximum performance in the case of ant colony optimization plus relevance feedback mechanism. But for other cases, right, it's almost within the limit, like less than 50%. Whereas the orange dotted line, right, it has maximum performance. They're showing maximum performance for all the cases for query 1 to query 8. Right. So why I should go for the fusioning of the text-based image retrieval? That is another question, right? So already I told you, like the advantage of the content-based image retrieval and the advantage of the text-based image retrieval were taken together, right? So the features of both the components are added together, and finally I got the good efficiency, better than any CBR or text-based image retrieval. So here also the text-based image retrieval, for that the textual feature extraction is done. In the case of the documents in the case of the query document, as well as in the training document, all the features. So here the features are like the terms, right? So whatever the terms, terminologies available within the document, so that those kind of terms will be extracted. So the features are fused together, right? The fusioning is also possible. So here I could go with the fusioning of the CBR and TBR, and if you substitute alpha is equal to 0 here, then what would happen? The first component will be cancelled. So 1 minus 0, you will be getting only the TBIR. And if you substitute 1 here, so 1 minus 1, 0. So your content-based image retrieval will be enabled. And if alpha is equal to 0.5, so both you will be taking the advantage of CBAR and TBAR, right? So this is the environment, my retrieval engine environment. So here you could see initially some keywords are given. So these keywords, like some numerals are given here. So these numerals are like IRMA code, whereas it indicates each and every object. So if I have 10,000 images, all these 10,000 images are having some unique ID. So this particular ID, which represents the object which is shown here, right? This is the written image. And right, instead of the code, numerical codes, some text. This is the feature which is extracted from the TBAR, and this is one keyword which is given here. And if I search it, then I could get a similar kind of images which is representing the musculoskeletal system. But whereas you could see this is the knee image, but whereas in the second, this is in the third and fourth, fifth, or even other images, you could see some knee images are available, not knee, uh, some extremities are available, but whereas knee images are not available, right? And in the case of spine, if I provide spine, again, it is giving me the similar kind of images, whereas the directionality differs a lot, right? So here it is differing in this case. In this case, these two things are differing, right? So another thing is like using CBAR. So in the previous case, TBAR was enabled, and in the next one, the CBAR is enabled. And here, one particular image is uploaded, right? And I didn't give any kind of keywords, right? Simply a similarity metric was selected. An image is uploaded as like our Google search engine. I'm getting a similar kind of images, but what is actually happening? The directionality which differs a lot, right? This one and this one and this one, right? Though it is showing a similar objects, but the directionality differs a lot, right? If I go for providing the text and as well as the image, right? A TBR enabling fusioning of these two approaches, sagittal left and as well as the images, right? Except the last one, I'm getting, except this last image, almost all my retrieved images are similar, right? So what is the final performance? What is the performance of my system, proposed system, right? This is again about the pelvic. The performance of my system is about for a different kind of query, right? Starting from query 1 to query 8. For TBAR, when alpha is equal to 0, the precision is almost in between 70 to 80%. And whereas in the case of CBR, when alpha is equal to 1, it is giving 85 to 90%. And I am going for the fusioning of these two approaches. The precision value, it rises to almost 95 to 99%. So the overall efficiency is about 94.81%. This is what we achieved in 2015. Right. So, Sudha ma'am, can I go for another 10 minutes so that I can rush up the second case study?
Sure, sir. Sure, sir.
Okay, so how much time do I have?
Sir, up to 3 we have a session, sir.
Okay,
So,
I
okay,
think,
sir.
okay, yeah.
Carry on.
Yeah, so this is about the case 2. This is the case study is multimodality medical image retrieval system using the CNN, right? So whatever the approaches we developed earlier, it's all based on the machine learning approach, right? So we need to focus only on the features, right? So feature extraction plays a major role in the case of earlier one, right? So but again, it is not providing an efficient system. It is not like efficient system, right? So because we didn't have different modalities, right? All the images what we considered earlier is all about extra images only, right? So here in this case, just we considered different types of modalities, right? So here you could see the different types of images, right? Brain CT, brain MRI, and even breast mammogram, and the MRI, mammogram, MRI, chest CT, chest X-ray, fundus, OCT, kidney CT, knee X-ray, liver CT, liver MRI, and again we also taken up this IRMA database and skin clinical and dermatoscope, right? So all these images were obtained from the different publicly available database with the protection of the copyright forms to them, right? So totally we had around 49,000 images. Even we raised our database to 49,000 from 12,000 images to 49 plus images. It's full of 2D images, whereas it represents almost 15 classes, 15 different classes, like starting from CT, MRI, mammogram, and different stuff are available. Right. So we started developing few CNN models for this diversified images, which is generated from various modalities. Right. So just we taken up the advantage of the very earliest model, the LANET and AlexNet, and slowly started developing our own CNN model. So for that, we have taken the softwares, right? It was implemented in Python, and even we had some lower end workstation, NVIDIA GeForce GTX 1060. And this is what the sample of images, right, which are all considered for this query images, right, brain CT. So what we have considered earlier, right, 8 query images were considered. But from this, we have taken almost 15 classes from different sources: brain CT, brain MRI, breast mammogram, breast MRI, and skin clinical, skin dermatoscope. So everything was increased. And this is the known architecture, LANET architecture. So which is the which comprises of the convolution, max pooling, convolution, fully connected layer, and as well as the Gaussian connection. And again, this is AlexNet. Here, the architecture is also predefined one, so you cannot alter it anywhere. And this LANET and AlexNet, which resembles our ANN, so absolutely we should have some weights, biasing, and other optimizers. So for that, we should have the SGD, ADAGRAD, and ADAM optimizer in order to reduce the loss function and as well as to take care of the weights and as well as other learning rate, right? So in order to compare the both features, right? So previously we had like Euclidean to Spearman. So here we have taken only the Euclidean similarity distance measure only, and as like the previous case, here also we have taken the retrieved images to be 20, right? Again, same performance metrics, precision, recall, F score, and apart from that, we could also we added the retrieval time and as well as mean average precision. So once you take up the predefined network, just we started training the network. So for that, we splitted the database into two. One is training database and testing database. So this is total number of images what we consider, right? So if you add it, I think you could get around 40 plus 40,000 plus, and here the test data would be around 1,000 something, right? So we categorized all the images into training dataset and test dataset. So as like the previous case. So once you train your model with the training data set, then you could get the curves, right? So for that, we could go for the, we could observe the training duration, validation accuracy, validation loss for the different epochs. So for that, we should get the validation accuracy of maximum. So we stop it 98.82. But when we are applying the RM optimizer, and even the validation loss is also reduced, and whereas it took only 68 epochs, it's optimal one between 10 and 85. So the Adam optimizer is useful in the case of Linux architecture. And once you get the results using this Linux, so this is about the brain city, whereas the query image is given, yeah, you are almost getting the similar kind of images, right? Except this one or two. And liver city, again you are getting the similar kind of images, but in the case of chest x-ray you don't get any kind of images which is retrieved here, right? It's absolutely entirely irrelevant. Right, so just we gone with another network, AlexNet. So here also we take up the predefined model and we train the AlexNet using the training database, and the training duration and validation accuracy, everything was considered. So here it took around 99.29% in the case of training the network for 100 epochs, but whereas it converged in the 75th epoch itself, and even the training duration is about 6,000 seconds, right? So these are the results from the AlexNet. So the query image is given, right? So yeah, I am getting similar kind of images, but whereas in the case of chest CT, right, I don't get any kind of then and there, right? Even some OCT images are also appearing, right? Here skin dermoscope is given, but then and there we are getting some irrelevant images. So what is the summary of the AlexNet and LayNet, right? From these two models, right? I'm getting the mean average precision of 86% in the case of AlexNet, and in the case of LayNet it is 83%, and the retrieval time is it's almost equal to 0.25 second, and here it is 0.21 second, and features extracted it's all about 1084. But you don't think I have instructed the features here. I didn't instruct any kind of features to be extracted. The features are all extracted by the network itself. The overall classification of accuracy is 99, and here it is 98%, right? So just after this, we started thinking about why should we go for the unsupervised one. So we normally we have supervised and unsupervised classification and as well as the retrieval system, right? So in order to go with the supervised, you need to instruct so how to do the classification or how to do the retrieval system. But again, this supervised is taking much time by any programmer to initiate the instructions to be given to the particular model. So what we thought had a thought like why can't we develop unsupervised model? Then we started thinking about unsupervised model. So for that we developed RESTcoder. RESTcoder is RESTnet plus autoencoder, the combination of RESTcoder and autoencoder, and this combination just went on well, and with this combination we developed unsupervised RESTcoder, unsupervised learner plus autoencoder, and finally we got this unsupervised RESTcoder model. It is 3x3, and whereas it gave us 80 percentage, right? In supervised model itself we got actually around 89%, but supervised it gave us a lot of efforts to develop a particular model or to be trained. So we thought of developing an unsupervised scorer model. So finally we got it 80%. Yeah, supervised here it is 87%, 87.4, but whereas in the case of unsupervised here it is 80.04. So still we have a few more research avenues in the case of image retrieval system, and the first one is like whatever the images we considered for the image retrieval is all about 2D images, but you all know nowadays the 3D medical images are playing a major role in the case of diagnosis and other kind of stuff. So we are also proposing 3D medical image retrieval system, and even the second one is about the patient information is not considered during retrieval process. So even the patient information or other kind of stuff must be labeled along with the images. And the third one is no benchmark retrieval algorithm is being developed as of now. So it is possible, right? It is still you have venue to develop any kind of benchmark retrieval algorithm. And the next one is the integration of IoT with medical imaging modalities is a gateway to manufacturers. So as of now, if you look up any medical imaging modalities, right, which is not yet built with IoT, and if you go with the Internet of Medical Things, then there is a huge scope for any kind of images to be retrieved from anywhere, right? And the implementation of hybrid intelligence is not at implemented, so that even you can think about a kind of a hybrid kind of optimizers, right? So whatever the optimizer I shown you, like SGD, Adagrad, and Atom optimizer. So it's all inbuilt optimizer. But once you go with kind of bio-inspired algorithms, in the case of feature optimization and as well as the epoch selection and other parameters like stopping of the epochs or the learning rate, fixing the learning rates and loss calculation. So if you go with the different kind of hybrid optimizers, then absolutely you can attain 100% in the case of multimodality image retrieval system. So these are the this is for your information, where we have few medical image database, so you can get it from get images from different publicly available database, Voyasis, ADNI, Fitbit, Stare, right? So all these, from all these publicly available database, you can get your images. Yeah, that's all about medical image retrieval system. And still you have a lot of venues to work on this image retrieval system. And if you have any questions, you can ask me.
Participants, if you have any queries, please unmute yourself and you may ask your queries. Or you may type your questions in the chat box. Yes, do anybody have any questions? Okay, thank you then.
Yeah, okay.
Thank you. Thank you for your informative session. We heard a lot of information from you, from your side. It will be surely useful for all the faculties those who are in this session. Surely it will help helpful for them in the research area. Thank you for your presentation, sir. On behalf of our college management, principal, our HOD and staff, we thank you, sir, for your informative session. We got a lot of information from your presentation, sir. Thank you once again. Thank you all.
Yeah, so I thank you thank you all in listening, and also thank the organizers and participants. If you have any questions, you can post a mail to my mail ID, which is given here. And yeah, thank you all.
Thank you, sir. Thank you, sir.
Participants, please submit the feedback responses in the next 30 minutes. By 3:35, the feedback will be, the response, we will stop the response, receiving the response. So please submit the feedback response before 3:35. Right, you will consider it for both feedback and attendance for this afternoon session. Thank you.
Dear participants, we'll meet you again in the next day, tomorrow at 9:30 p.m. Thank you. Thank you all.